Hey folks, welcome back to the class. Hopefully you got a chance to review the video on circuit theory. In this video, I just want to go over how to use LTspice. So here I am on the Canvas page, and under the first module, you can find the LTspice Information Center. So if we open this up, it'll take you to the Analog Devices landing page. So LTspice is a free spice simulator software, right? This allows us to analyze circuits without actually creating them physically, which can be super helpful. And you are welcome to download LTspice here. We'll be using it in the class, so please download it on your own machine if you have one. The machines in the lab actually have LTspice installed already, as well as some of the machines in the student project lab, which everyone has access to, also has the software installed. But once you have it installed, we can go ahead and open up LTspice. So you'll be welcomed with this kind of small little window here, and you can just open or start a new blank schematic. I'm just going to open this up. So it's a little tricky on Mac. On Windows, you have like a full toolbar up here that for whatever reason is not available on Mac, but on Mac you can right click this blank space back here and we can add components. So what we want to do first is add a voltage source, and we want to add a resistor. And you can rotate these by hitting Control R or Command R on Mac, whichever one. So I'm just going to take a look at a simple circuit here, maybe a little voltage divider. So this V1, R1, and R2, these are called reference designators. When we have a large schematic, it can be helpful to enumerate the different devices that we have going on. So voltage sources usually has this V prefix, and resistors have an R prefix. And on the bottom here, we have the value, right? So this is where we would say, okay, I want this to be a 5-volt source. So I'm just going to type in 5. And I want this to be a, let's say, 1K. So you can put a K to denote times 10 to the third, so 1,000. And we can also put 500 M to denote milli, so 10 to the minus 3. I think I'm going to maybe make the voltage source 500 millivolts. So that's half a volt. And now we want to connect our circuit. So to do that, we would go here, draw in our wires. And you can kind of click anywhere. So it has this crosshairs. You probably want to click here, line it up. And you can just go straight through, right? So it's a single click. You're not dragging this. You can just click here, go through that, line it up, knock them down, and tie it back here. Cool, so we have our circuit. What we need now is to have a net name. So we need to define where our ground is. You can click on this one, call this ground. We'll call this bottom node ground. And maybe we want this to be kind of like an output. So we're inputting 500 millivolts, and this is kind of like our output. So we'll call this node maybe V out or something descriptive perhaps. And I guess in the lab, you don't really have to do this. Another thing I always like to do is start off with a comment. And this is just to tell me what this circuit does. So this is an example circuit for E251. So here is our little comment. And what you might be thinking is, now let's simulate this. So this running man in the top left, running person, lets you simulate it. But before you can simulate it, you need to specify how much time you want to run it for, right? So if I try clicking it, it says no analysis command found. And to do that, you would need to draft this spice directive, which, sorry, this comment before is a spice directive, and I'm used to hitting the shortcut S key. So if we click on this, right, it lets you choose a comment or a spice directive. And what we want to do is a time domain analysis. So you can do .tran for transient, and you specify a start time. So we'll start at time 0, and we'll maybe run it for 10 milliseconds, 10M. Well, it's just a DC analysis, so it's not super interesting. But we can run it, and it pulls up this nice little oscilloscope, right? So this would be kind of like a time domain signal that we're looking at. And now that we're in the run mode, you can click on various points in the circuit. So if you're clicking on a node, you can look at the voltage. But if you click on a device, you can look at the current. So I'm going to look at the voltage here. Not sure why that keeps going back. So we're gonna look at the voltage here. All right, so that's 500 millivolts like we expected, and the output down here at 175-ish. So I think in this first experiment, we're actually not going to be running the simulation. We're just going to be constructing it in LTspice. So I'll go over more on how to run the simulation and deal with the scope captures in a future video. But this concludes the LTspice introduction. Thanks for joining us. See you in the next one. Bye.